All right. Well, I think we're all present and accounted for. So let me go ahead and start. First, happy World Space Week, everybody. We're happy to be gathered here to help celebrate World Space Week. And this particular theme for this year is Women in Space. And so we're happy to celebrate all of the women that work in the aerospace industry and have been to space and work to support those folks on Earth. What we thought we'd do is put together a little bit of a Q&A today on our upcoming mission through NASA called the Flight Opportunities Program mission under SpaceWorks. That is part of our mission at SpaceWorks in bringing payloads, science returns, materials, experiments back from space down to the people of Earth. That's our long-term vision. I'm Dr. John Oles. I'm the Chief Executive Officer at SpaceWorks Enterprises. We are located in Atlanta, Georgia, and we're happy to be working with NASA on this upcoming mission to demonstrate some of our return capsule technologies. And along the way, we're happy to make space in our payload bay for some exciting and upcoming students as part of our STEM outreach activity. I'm here to answer questions later and help kind of orchestrate the meeting, but I wanted to turn it over now to let him introduce himself, our program manager for the overall project, and that's Tyler Kunze. Tyler is with me here in Atlanta, and Tyler manages the entire portfolio of all of our re-entry capsules, including this particular mission. And I'll let Tyler introduce himself.
Thanks, John. So as John had mentioned, we are a company here trying to provide a small payload re-entry capsule to bring products and experiments back from space. And that works in microgravity experiments or in-space manufacturing. That is the product line that I work on here. So I've been managing this portfolio for about 2 years now, and very excited with the support of NASA to be able to get a flight test under our belts here in the month of October. For this actual flight test and this project, we are taking a smaller version of our product line of capsules. This one is called the Red 4U. The Red 4U can deliver approximately 10 kilograms of payload back from space. And by the end of this project, we will have validated the final 100,000 feet of reentry for this Red 4U capsule. And this 100,000 feet reentry condition will be the same as when we bring it back from low Earth orbit, hopefully in the next year or so. So at this point, I'm going to show the concept of operations for this mission. Can everyone see that?
Yes.
Okay. So this is the mission that we have set out in front of us for October 19th. In order to get to 100,000 feet, we are working with Near Space Corporations, which is based out in Oregon, and they have developed a high altitude balloon for us to fly underneath. So as you can see in the bottom left here, this is that high altitude balloon, and we will be connected as a capsule underneath. We will float up at about 1,000 feet per minute. Take an hour or so to get up to 100,000 feet. We'll then get there, float for a bit to get to the optimal drop location, and then we will release the red capsule at that 100,000 foot condition. Shortly after release from the high altitude balloon, we will deploy a decelerator parachute. We call this a drogue parachute. This will happen at less than Mach 1 at about 25,000, 30,000 feet above the ground. After we're stabilized under this drogue parachute, we will deploy a parafoil at 20,000 feet. And this is one of the major things that we're testing under this experiment. This is a guided parafoil system, and it is all autonomous. So we will give a target location on the ground prior to drop, and then the parachute will do everything else to get our capsule exactly down to that location.
I'm not seeing a particular image. Is anybody else seeing it? Is that just me? Ah, there it is.
Oh, is that?
Yeah.
Oh, okay.
Thank you.
Sorry about that. Yeah, so we will deploy that parafoil at 20,000 feet, and it will do everything on its own to get down to this target location right here on the ground. And we will set that prior to launch, and the parafoil will take it from there at 20,000 feet. So that is the main goal that we are trying to validate as part of this experiment. We have previously tested that parafoil from about 8,000 feet. So going up to 100,000 feet is a major climb and a major technical hurdle that we'll have to overcome here. In addition to testing the parafoil, we're also validating our communications and sensors in suborbital environments. And of course, we are providing a platform for several student experiments that we're happy to test here. And so to as a quick transition before we open up to some Q&A, I wanted to show some of those pictures of the student payloads as they are integrated. So I will start with this picture here. So this is the final integrated version of the student payloads that we have to talk about a little bit here and have a lot of questions about how we came up with these cool concepts. But this is how they were assembled prior to putting them into the capsule. And then right here, this picture is what the final version of them look like inside our capsule. So as you can see, this is a flight-ready capsule with a lot of different harnessing, different critical components going on there. And then smack dab in the middle of our payload bay is where we have these experiments that we are very excited to talk more about. So at this point, Janet, I wanted to kick it over to you if you wanted to start us off and talk a little bit about the student experiments and kind of, I guess, give the students really a chance here to talk about how they came up with such great concepts.
Well, first of all, the Janet's Planet Astronaut Academy would super love to thank Sean Case with Enterprise in Space, who introduced us to you guys, the wonderful folks at SpaceWorks. And so from myself and my students, we just want to say thank you. As I'm looking at these images and looking at how many, thousands of feet it's going up into the air, congratulations, Brian and Sean and Catherine and Sachita. This is quite an accomplishment, something that you guys are going to be able to tell a lot of people about. What I want to do first, though, is I want to go to the Bartello brothers. I want you to tell us, and Brian, you can go first, and then Sean, tell us an experience that you may have had very early on that made you interested in space or want to think about space travel or exploration.
To be completely honest, our first inspiration of space came when we were about 4 and 6. We were watching your TV show. We would watch it every day. We'd memorize the theme song.
You know what? I am so touched, and it's nearly hard for me to believe that. And for anybody watching, I did not slip them a 20 to say that. So, so tell us, though, what is it about space that you love so much? Why do you and Sean, you can answer this or whomever, but what intrigues you about going to space or doing things that add value and going out there and seeing what's there?
Well, I just think when I sometimes go outside at night and just look at the stars, I used to not really know anything about the constellations until I really started to learn about them, I guess.
And what about you, Brian? What intrigues you about going to space or venturing out there?
Well, I think that learning about space can help us possibly advance, because I just feel like it's our destiny to go to space, to explore. Just sort of our nature compels us to explore. And I think that learning space gives us another frontier to explore. Because we think we know a lot about here on Earth, but there's a lot more that we don't know anything about.
And I really hope to become an aerospace engineer too.
Tell everybody how old you guys are, one at a time.
I'm 9 and Brian's 11.
All right, so I'll come back to you with another question, but Catherine, what is your earliest recollection of loving space or being interested in science and what that might look like to send something out there?
Well, a big thing that happened was in 2019, I won a scholarship to space camp, and that was really cool for me. It made me really want to go to space, and I just thought it was really cool. And I just think that just how it's the unknown, we should try to figure out what's there. And I think that's really cool.
How old are you?
I am 12.
Sachita, I'll ask you the same thing. Your story's it begins in Bangalore, India, but you've been bothering your parents about going to space since you were tiny. Tell everybody about that.
So, to be honest, I didn't really look at the sky much until I was 4 years old. So my parents took me on a trip to the planetarium, and after that, I was smitten with space, and I got like books and everything. And then we moved over to the United States, and I bugged my parents until they finally took me to the Johnson Space Center. Since we were living in Texas at the time, and we're still yet to go to the Kennedy Space Center. So yeah,
So it's been a long time, but you want to be an astronaut, is that true?
I do. I do want to be an astronaut because although we know a lot about space right now, there's a lot more we don't know, and I really want to explore what we don't know so that we can go forward.
How old are you?
And I turned 14.
And you just also got back from space camp. How was that?
I did. I got a scholarship to space camp as well through Janet's Planet. And space camp was amazing. It was the best experience ever. Really makes me more determined to be up there one day.
Excellent. All right, Brian and Shauna, coming back to you. What are your plans for the future in space? What are your personal plans?
I plan on being an aerospace engineer, and I also made a couple of rockets by 3D printing.
Oh, show us those.
I have this one, which is a Falcon Heavy. I have a Saturn V, and I also have another Falcon Heavy, which isn't, but you can see it clearly doesn't have engines.
Did you 3D print those, Sean?
Yep.
And did you teach yourself how to 3D print? I thought I heard something about that.
Yeah. I kind of just made it and fiddled with the buttons, and I kind of just figured out how to make and print stuff. And
Excellent.
So, Brian, what are your future space goals or space plans?
So, I have a couple things. I hope to major in astrophysics and law so I can be a space lawyer, except one that knows what's behind the cases, because I know the astrophysics behind it. So sometimes they won't say things. I can understand it anyway. And it really gives me a deeper insight to maybe what I could do if I was a space lawyer. So I think that's probably what I would try to be.
I love it.
Things change. So yeah.
But you know what? I can hear you now presiding, order in the court, and you'll say, "Objection, Your Honor. I can park my Rover there." Sachita, we've heard a little bit that you want to do that, but what are your real space goals?
I mean, I just want to be in space. I know I love the Earth, but I do love space a little bit more. I'm sorry, but I do. So, and I really like to be there one day, actually experiencing it.
You know what? I can't wait to stand at your launch and know that you're headed to, I don't know, Mars or further beyond. All right, Catherine, what are your future kind of space and science goals? What is it that you want to add to our understanding?
I just want to learn as much as I possibly can. Like space, like its properties are so much more different than what we're used to on Earth. And I would just want to learn as much as I can.
Beautiful. You know, Matt, you as an interviewer and writer, is there anything you want to ask them before we sort of ask them about their specific experiments and how they came to the idea and landed on what they wanted to try out?
Many things. So first I'd like to know, are you guys up for adoption? I've been holding back the twins this whole time, and I don't think I'm the only one either. But yeah, actually, my first question, Sean, yes, and Brian, your desire to be a space lawyer Sorry, remind me again. Who wants to be a space lawyer?
That was me.
Yeah. So, are you familiar with the Space Court Foundation?
Yes, I am.
Oh, good. Yeah.
I
Well,
introduced him to that.
Very.
Oh, good. Yes. Well, that's what you do. Yeah. So that and the Space Generation Advisory Council. Yeah, you immediately made me think of that there, and that is definitely it's something we're going to need in the near future. So, kind of, do you have like a hypothetical case in mind, like what you're going to be called in to arbitrate on?
Well, mostly satellites.
Oh. Mm-hmm.
That seems to be a big one. Like, I believe that lately China's been testing certain weapons to to self-destruct their satellites. And there have been other satellites damaged by the debris of their satellite, and minerals too. I mean, there are going to be very good spots to mine on planets. And, everyone's going to want to be there, but maybe not everyone can be there. So they might fight over it, and I'm here to stop that. So.
Oh yes, and yeah, asteroid mining, lunar mining. Oh yeah, these are fraught with the potential for problems. So Catherine, next question. What was space camp like? Because I've never been. I'd just like to know what's it. What do you guys do like in an average day?
Well, Space Camp was sort of connected to the museum. We were able to go there, and I think personally my favorite part was the simulations because you could really feel what it was like. We did a lot of those, and we worked in a group. We built things, and we tested them out, which was really cool. But my favorite part was the simulations for sure.
Oh yeah. So yeah, so like rockets. You say you built and tested them. Were they?
We made like parachutes, and you had to make sure that the marbles stayed inside the capsule, and we tested that out.
Well, that's good. Yeah. Sachita, same question. What did what did you like best? I think would be the better one.
Well, what I liked best was that we did 2 missions. One was a Mars mission and one was a lunar mission. And I like the missions a lot because on both of them I got to experience different roles. So on the first one I was in mission control and I was the SOCOM. And the second one, however, I was the EVA and I got to be on the space station.
Wow. Well, that sounds great.
Could I just interject, Sean? You've been pretty vocal and very open about something that you overcame. Would you mind talking about that? Because I think when you talk about it, it's so powerful and only if you feel comfortable, but you've shared it with other people. Do you want to tell them kind of like what you have been overcoming?
Yeah, my dyslexia. It's been hard for me to read most of my life and spell, but I'm mostly overcoming the reading and spelling. But it helps me a lot of reasons. Like I can think of stuff in my mind, and that I'm also eagle-eyed, and I think outside the box a lot, and and I'm really good at puzzle solving too.
So really your learning awesome turned into a bit of your superpower there. So he's been and you've also been able to encourage other people to like say, hey, this is the way I kind of like am dealing with it, right?
Yeah.
Brilliant.
And
all right.
I like his term, eagle eyes.
I know
Yeah.
Eagle Eyes is
What
pretty.
is
So,
what was the quote? Steel-eyed missile man, or anybody remember
Yeah,
that?
right.
Steely-eyed missile man.
Another thing is, dyslexics mainly learn by doing things.
That's good.
yeah. You're well suited for a career in space and for engineering. Because yeah, it's like yeah, and you're alive at a good time too, because there are a lot of really good strategies for helping. Yeah, it's just you've got it all in your head there, but yeah, text can sometimes get jumbled when it's going from there to here. Yeah, and yeah, a lot of people got to deal with that. That's amazing.
Any other questions from you guys before we move on to asking them about their experiments?
I have one for everybody. Do you guys have a favorite rocket? Is there a particular rocket? I know, Sean, you showed before a couple of rockets, but do you have a favorite rocket, each of the four of you?
Probably the Falcon Heavy or the Sand 5. I don't know. I like them both a lot. I
Good
think
choices. Different
Sand 5.
generations, but good choices.
That's
Brian?
the Sand 5.
Currently Falcon Heavy, but I'm thinking about Starship too.
Okay. I was wondering if
That's
somebody's going to
also
mention
pretty
Starship.
interesting.
Starship is an up and coming one, is that should be fun to watch here pretty soon. Catherine,
Have a favorite?
no favorite? Okay, Sachita?
I don't have a favorite, but I would, if I had to, I'd pick the Saturn V.
Okay. I have a question for you, Sachita, because you talked about your experience at Space Camp. Okay, let's say you could only choose to go to the moon or to Mars, not both. You can go one or the other. Which one would you pick and why?
That is a highly unfair. But I think I would choose to go to Mars. Because it is unexplored, and I do want to explore it. Although I do want to go to the moon, Mars does seem very interesting as well.
Okay, Mars, one vote for Mars. Let's see, Catherine, for you, you talked about being an astronaut, that you'd want to be an astronaut. And nowadays there are really a couple paths. There didn't used to be, but there are. You could be a government astronaut and work as part of your job. You could work for the government and be a person working on the International Space Station or be a part of some of the deep space expeditions, or you could be a commercial astronaut and you could just go just for the fun of it, or go explore. What do you want to do? Do you want to be a professional astronaut for your career, or do you just want to travel in space?
I'd want to, if I were to go to space, I'd go to do different science experiments.
Did you follow, did any of you follow the Inspiration 4 mission that SpaceX launched recently? That was pretty cool, huh?
It was amazing. Very, very inspirational.
Yeah, right. Beautiful view of the Earth, staying in low Earth orbit, but yeah, kind of a neat thing to do. Okay, those are all my questions for now, but I'm happy to hear more about your experiments that you're flying with us. I also want to thank Sean Case. I didn't get a chance to introduce Sean earlier. Sean is with an organization called Enterprise in Space, and Sean has been a longtime partner of ours here at SpaceWorks and a supporter of what we're doing in a number of different areas, including sample returns and capsule returns. And he's a good friend of ours. And Sean is out in Oregon, where we're going to be doing the flight test with you guys. And we're happy that he has introduced us to Janet Ivey, and then also his friend, Matt Williams, who is the writer we spoke about before. So Sean, good to see you today. Glad to have you on board, and we appreciate all the support as always.
Thank you very much. Very excited with the whole mission.
Very good.
And his experiments.
Yeah. And let me also give a shout out to Paul DeLeon, who is our point of contact at NASA Ames Research Center. NASA Ames is one of the program executive locations for the Flight Opportunities Program that we're sponsored by. And Paul's been with us also for a long time. Paul was with us when we conducted our first drop test several years ago. And this is our second one that we're flying with him and his organization. So, and Paul's out in the Bay Area, in San Francisco Bay Area. But Paul, good to see you and welcome aboard. Glad you could join today as well.
Thank you very much. Good afternoon, everyone. I'm very excited to find out about the educational component on this flight, the student payload, really that adds a lot of value to our program, to NASA, to see students achieve their dreams and start getting involved in space activities early at age. Yeah. Looking forward to it.
Good.
I just want to
Yeah, I
mention real quick that I'm glad Soshita convinced her parents to take her to Kennedy and do that. I just want to mention that.
Yeah, yeah, it's a great inspiration. Janet, that might be a good segue back to you.
All right. So
So
Catherine and Sachita, I am going to throw these questions to you. The first one is, you guys, do you want to kind of tell everybody what the experiment is? Why don't we start there? Somebody, either one of you, say what you are kind of going to send up as your experiment.
Catherine, do you want to start?
Sure. So basically, what we're gonna do is we're sending up a thermoluminescent dosimeter up into 100,000 feet into the air, and then we have 2 on the ground, and we want to see the radiation reading difference between the 2 to find out how effective the atmosphere is at blocking the radiation and how much radiation you'll receive depending on where you are.
And what do you, I mean, you guys, what do you think, or what might this experiment indicate when it comes to how effective Earth's atmosphere is? I mean, what are you guys proposing? What's your hypothesis here?
Well, what we really want to see is if the radiation that is, well, up there, if it's higher than if it's down here. And our hypothesis is if the thermoluminescent dosimeter that traveled in the weather balloon experienced 2 times more radiation than the TLDs on the surface of the Earth, then the atmosphere blocks 50% of the radiation from entering the Earth.
Now, why did you guys choose that number? Was that you thought as a scientist that's a good number? How did you go about choosing that particular number?
We just used it as like an example, and depending on if that number changes, we'll know how effective it is.
All right, so you've got 1 TLD in the high altitude balloon. You're going to have 1 in Pennsylvania, 1 in Tennessee. Tell them why there's 1 in Pennsylvania and 1 in Tennessee.
So it's primarily because those are our current locations, but also having a dosimeter on the northern half of the country and then the southern half would like give us the idea of the amount of radiation difference received like in our area.
I want to ask you guys about what valuable information did you gain from the authors that you referenced in your experiment plan?
Well, it gave us an idea of what people have already learned, and we want to learn new things. So we just want to find out what we want, what we need to explore.
Because I see you read Why Space Radiation Matters, Atmosphere from the National Geographic Society, and then another kind of CR39 neutron dosimeter. What was kind of like the most surprising thing you read as you kind of did your research?
So we didn't really know the functions and the features of a dosimeter before this. So once we did research on it, that's what we found out. And it's actually a really cool instrument once you find out, because it does create like a permanent record of the exposure. So that was really surprising.
And you guys had some other opportunities to choose other experiments. How did you finally land on the thermoluminescent dosimeter?
Well, we tried multiple different things out, but a lot of times you run into problems and certain things don't work. That's why you need to try different things out.
There were
And-
always like unforeseen constraints that we could not overcome, so we had to try changing experiments. I believe this is the 4th idea that we had, and the one that finally worked.
Beautiful. Any
That-
questions from everybody before we move on to Brian and Sean's experiment?
I just want to say one thing, that the other things that you guys tried weren't a failure. You wrote up great papers on them, and you can just try again the next time. Because you didn't fail at anything, and you wrote beautiful papers on some of the experiments that you were looking at.
That's the research process right there, right? We got negative results. That's not failure. We learned something.
Right.
Yeah.
I have one question about the dosimeters. So the ones you have for control, the one in Tennessee and the one in Pennsylvania, how do you manage the time of exposure? How do you correlate the times of the dosimeter that's riding with us in the capsule up to the high altitude and back down again over a period of time versus the ones that are being exposed to the same time in Tennessee and Pennsylvania? Do you correlate the times in any way? Or does it record data over a long period of time?
It records data over a long period of time, and right now it is in like a spot where it cannot receive any radiation somewhere in our houses, and we plan to take it out once once on the launch date, once it is launched.
Okay, very good. Yeah.
Any other questions for the ladies?
Yeah, I got a quick question. What made you choose that specific dosimeter? Were you considering other models or units? And what made you decide on this one that you're using?
Catherine, do you want to answer this? I'm pretty.
Did you do any testing on it to make sure, or read the specifications to see if that was the right one for the environment that you were going to be exposed to?
Yes, we did read what the qualities of the thermoluminescent dosimeter was, and we thought that it fit the project, was the right size, and could accurately record the radiation. So we chose this TLD.
Okay.
As I recall, I did assist them in doing a bit of research on where we could find those dosimeters. Some of them only pick up certain kinds of radiation. This one, the model that they chose, has the ability to pick up and to see if there are gamma rays, etc. So that when we read that piece of it, we thought, oh, that's what we need to send up.
Great, thanks.
All right, Brian and Sean, why don't you tell us the name of your experiment?
So, hello, my name is Brian Bertello. I'm in technically 6th grade, yet I'm taking higher courses for math and chemistry. So we are doing seeds. We are going to send up squash and pea seeds.
Here's also
And yeah,
this
we found these vials. And you've probably already seen we made a 3D printed case for these vials so that we don't break the seed, because that would impact the results as it possibly shakes. And well, we want to see how quickly it germinates, how much crop it yields, and inside of the fruits it has, if any. Then we want to see how many seeds each of those have and how viable those seeds are. And we're planning to chart the dependent and independent variables on a data chart. And overall, we're going to see what happens to the seeds. And from the research I did from the library portal of the local college that I go to, I have thought that my research has led me to believe that the seeds will probably grow slower after going to space. So that's my hypothesis. However, it could be false. So we're going to test that to add to the data set. And we are going to we're using peas and squash because these those haven't been used as much as we're using these instead of tomatoes, because for us, peas and squash have an exceptionally high germination rate. So we're going to be able to test the difference to see whether it went slower, faster, or something else happened to it from the space trip. And yeah, that's our experiment
And
in a nutshell.
hello, my name is Sean Botetta. I am 9 years old and in 4th grade, and I'm homeschooled, and I take I also take Johns Hopkins music.
Oh yeah, I forgot. So do I. We both do that.
And
Wow.
as Brian said, I 3D printed the box for the balloon test.
And that was one of the things we knew early on, the constraints. And so the Bartello fellas actually took it upon themselves to 3D print their own vials and everything. Tell us how that process went, Sean, and why did you want to make your own containers? Because I said it just has to fit inside, something that would hold a deck of cards. Why did you want to go to all that trouble to print your own?
Because I didn't want the other experiments maybe damaging the seeds. So I made a case so it doesn't move around it a lot or run into the other experiments. So that's why I made the case. And I got the exact measurements by using a micrometer, which is best. You just extend this, and it just says a number of how big it is. For example, just these seeds.
Perfection.
The software I used to do 3D printing, I used Ultimaker Cura, which is a CAD software, which is how I printed all this and made it.
That is so genius and wonderful. I'm so proud of you guys. What did you find most interesting when you were researching other organic plant matter types that have been tested in space? What did you discover that you found interesting, or maybe pointed you away from and pointed you toward sugar daddy snap peas and the black beauty summer squash that you chose? What did you find most interesting when you were diving deep into your research?
Well, it hasn't all been done, and since the first one was a potato, I didn't see a lot of tests that went into space or high altitude that carried peas or squash, and so I figured those would be interesting. And tomatoes are common, so not those. And squash and peas, we decided to pick the two that work best, that have the extremely high germination rates and yield a lot of fruit for us. The ones that specifically work the best for us are Black Beauty and Sugar Daddies. And we want to see what the difference is and how, for example, how much fruit it'll produce rather than the last time, because we love gardening, and last year this year we planted these same seeds. And we have a little bit of an idea of how they should grow normally. And so yeah, those two were the controls, and we're gonna see, will be our experiment, although we're gonna also have a control growing to compare what's going on between the two and how it changed.
I just love the fact that it's like once you plant them, you can say space squash. Right? Space peas and space squash. Paul, do you have any questions for the guys?
Yeah, as I understand the experiment, you have selected a batch of seeds that you're going to expose to radiation and space environment and near space environment, and then you're going to have another set on the ground, and you're going to grow them side by side and compare both of them. So
Yes, sir.
how long do you think, when are you planning to get your results? When do you planning to plant the seeds? You know, we're getting close to winter,
Maybe
and I
next
don't know if you're
spring.
gonna wait until spring to do that. So
Yeah, because we don't want to risk the plants. We want to see if it actually works. So we want to make sure it actually grows and that they can handle the correct amount of heat. Because in
You
Buffalo,
guys aren't
it's very
planting them
cold.
until the spring. Is that what you're saying?
Yeah, because here in Buffalo, it's very cold in the fall and winter, and I don't think the plants could be able to stand that. But maybe in the spring and summer, they'll be able to stand it. Then we'll try and plant them and see how they grow differently.
do you have a theory? What do you think is gonna happen?
We think from what my research from the college I go to's library portal, the books and articles I've read, it leads me to believe that my hypothesis is it should grow slower, but we don't know for sure. That's why I'm doing this, to add to the data set so we can all have a more accurate sense of what it should be, what should happen.
Great, nice experiment, great experiment.
Thank you.
So some of this, maybe you're going to have to add astrophysicist, space lawyer, and food consultant for the ISS, for the International Space Station, if you're finding foods that, grow well up there.
You'll just have to call Joya Massa and go, Joya, we know you're working on, growing hot peppers in space. How about squash and peas?
Yeah. And for the space law, I have Sean helping me as a mentor. So thank you.
You're very well.
So one recommendation will be to keep the same environment. Once you plant them, use the same kind of soil, plant them right next to each other, the same amount of sunlight. So you minimize the variables that you introduce when validating your experiment.
Thank you, sir. And we'll garden a lot. And since we're bringing up a few seeds, we can more accurately test, because who knows, maybe one seed's going to be duller than the rest. Maybe it won't grow as high. Maybe it'll grow much more. So we're bringing a few of them, like maybe 7 to 10, maybe 12, to plant a variety and then count the average out, see what happened to them and see whether they grow faster or slower or who knows.
So I have a quick question here in regards to this, and I don't know the answer.
Yes, sir.
But can you tell how much radiation the seeds have been exposed to by the dosimeter?
Actually, probably. I might know.
Great opportunity to collaborate with your partner.
And to collaborate with the dosimeter experiment to see, okay, exactly how much radiation were they exposed to, and
see how
something
that
to know.
affected it. Great idea.
Beautiful.
These plants
John, Matt, or Tyler, you guys have any questions for anybody?
Yeah, I have one. Do you think or expect to see any difference between the two different seeds from their exposure in space?
Yes, sir. We do. We expect that they'll grow slower after space because of that's my hypothesis after what I've read from my library portal from my college. I've read a lot of the articles and books about it. I did my research, and it leads me to believe that they should grow more slowly. However, that's why we're doing this. We're not completely sure. It might change.
Do you think they'll shrink or expand or look weirder?
Maybe.
Do you think either the peas or the squash would be more resilient to the space exposure?
Maybe the squash would.
Does
Oh, sorry, Matt. I was going to say, do you plan to eat any of the squash or the peas that come from the space seeds?
Yeah, what do you think?
Would you eat it yourself?
That is, if they grow, then yes.
What if it grows to like
Okay.
half the height and seems kind of weird compared to the other one? Would you still eat it?
Maybe not. Maybe.
Probably
I don't know.
probably won't hurt them, but you know. Okay.
Most of it's
I'll
for
make-
for the sake of science.
Oh,
Yeah, you know, you got to make, as a scientist, there's a lot of sacrifices you got to make.
Yep.
And probably as a lawyer too, just say.
Yep.
Mhm.
I'll do an attempt at a
Yeah.
small funny here that if he grows Jack and the Beanstalk and creates a space elevator, then we
Oh,
thought
God.
of it here first. You thought of it.
Yeah, yes.
Yeah, I like it.
Yeah. Well,
And then you can
so
sow seeds from that seed as a second generation seed to various people around your town.
Yeah.
mhm.
That's another thing we want to test is if if it succeeds and the plants grow well and they have fruit, and we want to see how the second generation seeds grow in comparison to the ones that have never been to space and the ones that went to space, the first generation. We want to compare that.
And then you've got your own entrepreneurial business, Space Squash, and you can charge a
Mhm.
lot for those amazing seeds.
Probably
They're,
won't
they're
charge a
space
lot.
heirloom seeds, right?
Yep.
Mhm.
Maybe. And Sean and I love to garden. So.
Yeah. We made a
You
huge
guys-
garden, but
You guys know that what we do in space also benefits Earth. You know, the Earth observation satellites, farming,
Mhm.
all of it is about both Earth and space.
Mm-hmm.
Mhm.
And
Nope.
we can't
I got
wait.
a question.
We can't wait to get them back and plant
Mhm.
them.
So I got a question. Sean and Brian, does anybody ever compare you to Mark Watney? And do you know who that is?
Yes, we know who that is, and no, not yet. No, they
Yeah.
haven't compared us to that yet, or they don't really know about it. I should
Mm-hmm.
mention it, but yes, we know who Mark Watney is. Christian.
Good. Yeah. Well, yeah, you guys are up on your pop culture references. That's pretty good. Yeah, this I have noticed the subject that film. The reference is made often whenever anyone is talking about growing plants in space or developing agricultural methods for other planets. Frankly, I'm sick of that reference. It's like we do, you know, other people have worked on this. It's not just in the movie. Thank you.
Yep.
Yeah.
And we can't wait for them to come back, and we'll plant them after. We'll be planting seeds that went up to the edge of the atmosphere.
yeah, I love the garden too. It just, I can't wait until we can see if there's any differences between the regular plants and the space plants.
Mm-hmm.
And
But
what?
you guys,
Oh, go ahead. Sorry, Matt.
yeah, no. Let's say you could expand on this experiment here. Do you think it would be really awesome to have a satellite in orbit that was basically an automated agricultural operation, right?
Yeah.
Yes, we would.
That would be wonderful, wouldn't it? Yeah.
Yes.
I was thinking that too, like flying a enclosed terrarium as an experiment.
Yeah. And if it rotated, it could simulate gravity at different levels. Oh dear. Okay. We're going somewhere with this.
Excuse me.
One of the things that I want to, and we've talked about this, that I encourage you is that when you do get these things back, of course, we'll be sending all 3 dosimeters to a lab to kind of get that data. The data will go back to the girls where you guys can take a hard look at it. What do you think you'll feel as you look at those results? What will it be something like, oh my gosh, we've got to do more to protect the ozone layer if something disastrous is kind of like discovered? What do you think you'll find or feel about what the data reveals?
Well, we garden every year, so if we see something different or weirder than normal, we'll know and we'll be able to see.
What about you girls?
I think I'll be excited if it's something new or different, but I'll also be really curious about why it happened and what I can do to figure out if it's bad and something needs to be fixed, or if it's good.
Mhm.
Wonderful. Any last thoughts? I'll throw this to you, Sachit. I'll begin with you. If somebody out there that is your age and listening, and they're not sure about something, maybe their plan for the future, what do you have to say to them about doing science or doing experiments or thinking about how whatever we do out there in space could benefit Earth? What is your message to your peers about why getting involved in something like this is pretty awesome and really crucial for what we're going to do in the future? Oh,
Oh,
Back.
yes. Did you hear my, yeah, go ahead with your answer.
I didn't hear the last part, but I did hear the first.
Yeah, what would you say to your peers about why doing something like this is really amazing and why considering a career or future in space is a great idea and one that you are going to pursue and why they should come join you?
Well, like I said before, there's a lot to be explored in space. So the more people we have working and interested in it, and even if it's just like what Brian wants to do, like space law or aerospace, anything, but it's just very intriguing. And even if science and space isn't your thing, you should just follow what you want to do. But then again, join us.
Well, the thing is true. It's like we won't just need scientists and engineers in space. We're going to need artists and painters and those people that can express what you guys have been discovering. Catherine, what's your message to friends of yours out there who might be watching or peers that you say, come on and join this, at least give it a try? What would you tell them?
My message would be just, you don't have that long to be a kid, so try everything and see what you like, and if you think that you really like it, then just go with it.
Perfect. Brian, what do you say to your peers?
Just whatever you want to do that. Just don't. If somebody says don't do that, just do it. Do it anyways. Nobody has control over you. Don't do it, you can.
What about you, Sean?
I'd say follow your dreams. And when you start failing on something, never give up. Just keep on working.
And as you guys have heard me say before, Einstein always said that if your idea is not absurd enough, there is no hope for it. And I can only imagine that somebody might have said that to Mr. John Olds, who said, you're going to do what? You're going to start a company doing what? You're going to fly balloons? What? Did that ever happen, John?
Oh, I'm sure it did from time to time, right? When people say you're going to be an aerospace engineer, you're going to get involved in space program. It's a dream, and dreams do come true to the young folks out there. So I encourage you to keep following your dreams. You guys are on exciting paths in your education and your careers. You are the next generation of aerospace professionals, whether you be space lawyers or aerospace engineers or astronauts. We want you to join us. And so it's fantastic to be working with you on this flight. You have some great scientific experiments that you're exploring. You're getting involved in space flight or near space flight at a young age. And I want to thank Janet for introducing our company to you, and also Sean Case for introducing us to Janet. So we're excited about this, and we're really pumped. Looking forward to flying with you on October 19th, weather permitting. You know, that's the scheduled date. We'll go up and down and see what it looks like up there, get some great pictures, give you a free fall on the way down and then a gentle glide down to the touchdown and get your experiments back, and you can start doing the rest of your science. So congratulations, pleasure to be working with you all, and thanks for the update today. I'm really fascinated. You all are on top of it. You're smart, you know your experiments, and you speak well, and I'm glad to have met all of you.
Second
Why
that.
don't you guys tell them thank you individually? Catherine, I'll start with you.
Thank you all so much for this opportunity. It's really valuable to me because I really want the experience. So it helps me learn, and I can learn new things and build on my past knowledge.
And Catherine should also tell you, she's being a little bit humble. Tell them about winning that first robotics contest and what that experiment was like and where you spent your summer building an app with the department. You know what I mean? So tell them a bit about both of those experiences.
So in March 2021, I won a contest through ORISE, Oak Ridge Institute of Science and Education. The contest was basically design an invention that would help solve a problem. And I designed an invention called the Aquabot, and it basically uses thermoelectricity to condense liquid water out of the air for people that don't have access to clean water. So this could be used in like third world countries, but it could also be used in space, because since space is so cold and then you have the interior of like the spaceship, thermoelectrics would work really well, and you could get water, which would help a lot in space.
And tell them what you did this summer.
Also, I got accepted into this 2-week program with Joint Institute of Science and Education, and basically they had different groups of middle schoolers all around the country, and I was in the app design group, so I got to learn how to make apps.
Excellent.
All right. And
Woman in Space here. Woman in Space Week in future Women in Space as astronauts.
yes, and Brian, tell them which courses that you're taking at the college level.
Recently I just finished my math 136. And
But that's a little bit of calculus. You're being kind of like humble there, just to calling it math. It's like a little different.
calc, yeah. I'm also doing chemistry
at the college level. How about you and Sean? Say thank you to these good people.
Thank you.
Thank you so much for your time, and thank you for
everybody.
listening. It's an honor to fly with you, and can't wait until October 16th.
19th.
And yeah, well, 19th, depending on the weather, though.
And Sachita,
Fair enough.
she's my junior, wait a minute, hold on. Which National Honor Society that you're with? I forget. And all the other things you're doing.
Last year, I was part of the National Junior Honor Society, which was only for last year. The next thing is the National Honor Society. But I'm not allowed to apply to that until next year, I believe. So
say thank you, and then we shall all bid you guys good day.
thank you so much for this opportunity, and this was a great experience and really opened new doors. Thank you for your time too.
Thank you. Janet, can I offer one thing here? Sean, you addressed this earlier, right? How we're not just solving for space, we're solving for Earth. And yeah, I'm trying to figure out who said that, who's the first recorded mention of that, because as far as I can tell, it was Dr. Cyan Proctor. But when asked, she said, "No, I think I heard it somewhere," and so I'm trying to chase that down. But if she were here, she would definitely raise that again, and that's really what's amazing about the work you're doing. And I was reminded of that there, Catherine, when you mentioned your experiment there, basically making water out of air. Yes, everything that we do that allows us to live and thrive in space will have endless applications here on Earth, especially in a time of climate change. So don't stop.
All right. Anything else you guys need? John, Tyler, anything you want to say, or Paul, as we, I guess, end our time together?
Well, thank you very much for inviting me. and looking forward to this flight and the success of each one of the experimenters over here. And you have a great future ahead of you. So never give up your dreams. The sky's the limit, and well, limit.
Not anymore.
Thank you.
And I would like to personally thank SpaceWorks for the opportunity. Awesome. You guys rock. And I also like to say I'm here to help out the students on this or anything in the future.
Yeah, let me echo my thanks as well. So again, thank you, everybody. You guys are inspiring to me. You're doing great work, and we consider it at SpaceWorks, it's part of our mission to reach out to the next generation. And this was an opportunity that we saw early on, and Tyler and I talked about it. We said, hey, we have some extra space on board here. What can we do? And we reached out to you, Sean and Janet, and I think what we ended up with is a great solution. It's going to work for everybody, and I'm looking forward to seeing the results.
Excellent.
It is so exciting. We cannot thank you enough. And again, these students are amazing and genius. And I am just proud to be there to kind of like be their science cheerleader going, woohoo, you can do it.
Yeah. I'd like to also thank Paul for coming in on this too. Thanks, Paul.
Thank you, Miss Janet.
You're very welcome.
All
right. As the best socially distanced handshake that we now have, everybody live long and prosper. We will see your experiments in space